Well, thank you all for coming tonight. It's great to have a good crowd here. My name is Vince Allen. I'm one of the partners here at the firm, Carstens Allen and Gorley. I'm a patent and trademark attorney with a background in electrical engineering as well as some aviation-related experience as well. Got really interested in ChatGPT when it came out back in November of 2022. And so we started up this AI Thought Leaders series and hope to give various topics on various presentations. In the past, we focused on the software aspect, some of the risks associated with the use of AI tool. But today we're going to focus on technology and what's actually behind it, what makes it work. And but before we do that, I want to thank our sponsor, Insperity, and in particular, Nikki Nielsen. He's been a great person to work with. We've been using Insperity now for a couple of years. So I'm going to ask him to come up and say a couple of words for you before we get started.
Thank you, Vince. I appreciate it.
Yeah, thank you.
Hello, everyone. Nikki Nielsen. I'm with Insperity, and when Vince asked me, "Hey, do you want to be a sponsor and you can speak about HR for an hour?" I said, "Sure, I'll go do that." No, of course, we've enjoyed the partnership and love to be here. I have a brochure here. If your firm need anything in related to HR, because everyone loves HR, everyone loves to do it, deal with the complaints and the payroll and the benefits and all that stuff. We were started to help small business owners take away that administrative burden, the risk and the compliance about HR, and put in a Fortune 500 level infrastructure for HR. And so if you would like to have a conversation, let me know, because part of this is timing, right? So we just want to help businesses succeed so communities can prosper. And so let me know if you have any questions. I'll leave my cards up here and take it for sure, but hopefully this will be more interesting than HR, so I know it will. Thank you, guys.
Thank you, Nikki. Well, as I mentioned, ChatGPT is kind of what started it all, and when I started playing around with it, I realized that it was going to be revolutionary. And so I started looking at some of the potential legal issues that might be involved with using ChatGPT and other large language models, and of course, confidentiality of your inputs being one big one. So I started doing some talks about some of the risks that are associated with using AI and what you need to do to make sure that you use it properly. I was getting ready for a presentation for the Plano Chamber, and I ran into Rob, and Rob said, "Yeah, I've done all this work related to AI. I've got over 100 use cases already." I mean, this was a year after LLMs came out, and he had already been baptized by fire. And I said, "Well, you need to come, work with us." And he did, and we started up what we're calling AI Triage Center, which allows us to vet AI-related software products from beginning to end. And Rob is a big part of that. He's going to be our moderator today for the presentation. And so without further ado, Rob Taylor, let's get started.
Okay. I was just thinking about what you were saying about all the work I've done with artificial intelligence and use cases. Remember when the smartphone came out and people used to joke about how, I bet there's an app for that, and sure enough there would be one. And that was kind of how that whole era kind of got started, where these great technical innovators came up with ideas for applications to solve a particular problem or do a particular thing. And I feel like we're in kind of the same era now with the availability of generative AI, where it's almost kind of like the same joke to me, because I see so many of these use cases. It's like there's probably a use case for that, right? And that's what all my clients are doing, is they're building applications or generative AI solutions for specific purposes for enterprises to be able to take tasks that were formerly being done by humans and essentially outsource them to generative AI. as part of the workflow and such. So that's where I've been spending a lot of my time in the last 2.5 years, and have now vetted probably several hundred generative AI solutions on behalf of clients. I'm also involved in the AI ecosystem with one of my clients does AI data center development. So I'm really excited about this topic tonight and just learning that side of the AI revolution. And then we also have clients that do the small language models on the AI PC chips, which started shipping this year. So really have had a broad view of it, but until recently with my data center client, I really didn't get the full understanding of, what's an AI data center, why is it different, and it's the key to the the infrastructure behind all these AI applications that have been built and how they run, right? So why don't we let AJ start with you and introduce yourself and your background and.
So my name is Ajay. I started in technology as a software developer back in the mid 2000s. There was a time I wrote better Java and JSP. Then I spoke English. Spent a lot of time developing code. In mid to early 2010s is when I got closer to the customer and started working with data centers, deploying and integrating various systems that go in a data center, right? So if you think of a data center, it's a complex industrial building. There's mechanical, electrical systems, network, storage. So combining all of those, the data from all of those domains is what I've been doing since 2010. Been in almost all aspects of it as a user. These days I'm constructing and building data centers and retrofitting for some AI and some traditional use. But being around the block, worked with some startups, big and small data center companies, hyperscalers around the globe. Thanks, Ajay.
Hi, I'm Mark Bhuyan. I have been in the data center space for almost 20 years now. Started back in 2007, 2008. There was a company called Sabre. I think it's still around. And Sabre's still around, right?
Mm-hmm.
Yeah, Sabre back in the day, American Airlines commercial system. And my first exposure to data center was as a business analyst. As I was working for Sabre, they said, hey, we need to go visit the data center in Tulsa. I'm like, okay, it's another building. I did not know that it was an underground bomb-proof building. And that was the first exposure to data centers. And my love for data centers has been ever since. Moved to Bank of America, eBay, and right now I work at Google as a product manager working, building AI software to help data centers operate more efficiently.
Well, you already heard about
Okay.
it.
All right, well, let's get the show on the road then. Let's see. So, can one of you talk about what really powers all these AI applications that are being built and how do the data centers fit into this ecosystem?
Sure. We're going to, just the format of today's conversation, we're going to do it a little differently. I think you're used to a person presenting slides. We said that's probably the old way to do it. We're going to do it differently. We're going to have the slide as sort of the guide of what we are talking about, but we are going to have a conversation. So let's talk about AI. Let's talk about the alchemy of AI, right? Because it's the first time in human history that we are able to produce or manufacture intelligence. How are we able to do it? There are different components that go into it. At the highest layer, we've got data, and then we've got algorithms. So, the algorithms sort of the old way to use data, but now we have what we call is the LLMs, the model, which really has made AI quite popular. At that layer, we have OpenAI, we've got Anthropic, we've got Google, we've got Meta. All of these players are operating at the algorithm or the model layer, large language models as it's known today. At the next layer, we've got compute, which is the infrastructure on which the models are run. And that's where NVIDIA's and the HPs and the Dells, HPs and Dells in the past, but now more recently, NVIDIA is operating. And a layer beneath it is the data center and the energy that powers the data center. So we're going to focus primarily on the energy and the data center layer today in this conversation.
So to get started, why don't we go back a little bit in time and talk about where all this data center evolution started from?
Yeah, so if you look at the history of computers, right, way back when the computers were so big you can only fit one in this room, right? That's the mainframe era. That those were very, very early computers when they used to run on floppy disks and magnetic tapes. Then we evolved into modern computing, which is around the late 80s and 90s, is when real true enterprise data centers came to be, right? That's when the servers were deployed in a room, just keep the room cold, air conditioned, and that's it. That was the first data center. In mid 2000s, when virtualization came in, that's when the scaling happened of those data centers, right? Back in the day, I need to have one server for, or one physical server for one software server, right? It was one-to-one. When virtualization came in, we were able to kind of partition that hardware and then scale up, right? In 2010s, the hyperscalers and cloud computing really came to play. So I don't need my own data centers. I can subscribe to a cloud, and that revolutionized our industry, right? So that brought in a different model, different rack density, different market, different business almost, right? If I'm an enterprise connect or subscribing to my own data centers, my SLAs are different, my cost model is different. How I treat a data center, back in the day, enterprises were treating data centers as a cost center, right? With cloud computing coming into the play, it's a whole different business model. And then, in 2000s, right, social media was the other big influence behind creating these hyperscale data centers. And then 2020s came, the AI, we've seen the shift and demand towards later half of 2010. At 2016, 17 is when the industry started asking, we have more compute, we have more intense asks, right? So before ChatGPT is for, that's a November 2022, right? Remember that is a landmark date for humankind, because that's when AI became accessible. There was AI before that, just not as accessible for a normal human being to interact with in an easy way. Mark's been deploying AI and working with it way before that. So the 2020s just changed the industry, the way we approach and build data centers, right? Until 2010s, we used to build the shell, we'll build the building, we'll bring power and cooling and say, you guys can deploy anything you want, practically at that point, right? There was no consideration. We did not think there's any IT load that could not go in there. You want telecommunications, you want storage, network compute, research, supercomputer, bring it in. There was not a whole lot that could not fit in. Starting 2020s, when AI came in, now the data centers are being built inside out, which is where we define not only what rack, but what GPUs would go in. That would dictate my power and cooling requirement, and that would dictate my room, my rack size, my pod capacity, what network I need. So it has evolved, and so has the design, the construction, the operations of these data centers.
I think it's interesting to talk about data centers with such an interested group of folks. Back in the day, when I used to say that I worked in data centers, I mean, even folks who were pretty technical would like just have like what's a data center, right? From that, we have evolved today, where a lot of interest in data centers. But this is not the first time we are seeing data centers. During the 60s, like Ajay was saying, we had mainframes. Right? Mainframes were hosted in an underground room in Oklahoma, which was also liquid cooled back in the day. Then we moved into more enterprise version of data centers, which actually started as just data closets. One room in a building with a couple of racks, having an air condition dedicated particularly for those racks. I mean, that's how we really started the modern enterprise data centers. During 2007-8, a lot of hyperscalers, Google started deploying a different form factor. You guys know about a shipping container, right? Imagine a shipping container with racks in it deployed in rooms. So we moved to containerized data centers, because it was just a lot more faster to deploy one unit, a container as a unit. And then eventually, during the 2015, 2016, we started seeing huge hyperscale deployments. You're looking at buildings that are about 80, 90 megawatt worth of power capacity. Just to give you a reference, 100 megawatt building is consuming the same power that 100,000 homes would consume. You're looking at a rack today that consumes almost equal amount of power or electricity. Compare that to about 10 homes in a couple of blocks, 10 homes, same amount of power consumed by a rack. And rack is, same form factor as a refrigerator, right? Smaller than a refrigerator. So the scale of how this is being deployed is unprecedented now. And we're going to talk about what's different between the enterprise data centers and the AI data centers in the next few slides.
Yeah, I think what's really fascinating is the whole, this whole history. It's about the densification of compute. What used to be able to be done with a very large computer, then came the PC. But when you think of like enterprise type data processing, just the intensity that has been just distilled down into these large small formats, right? And so, the NVIDIA chips keep getting more powerful, the GPUs. And so, but the trade-off with that densification of compute becomes the heat generation that they put off, which then is why legacy data centers that were built for AI don't work, because they just cannot cool efficiently enough to accommodate the heat being generated by these really dense computing GPUs. So we have on the next slide a short video of that Microsoft put together of.
Quick show of hands. How many of you have been to a data center, have seen one? Okay.
Quite a few.
The view may be generic, but this is actually one of my favorite places in the world. Why? Well, I think it represents the most important infrastructure of the 21st century. This is a part of Microsoft's Columbia data center campuses. These house the computers that fuel our lives. There are more than 20 buildings, each large enough to house 2 commercial aircraft. They fill 2 million square feet. They're spread out over 300 acres. But what's really interesting is what's inside. It's something that almost no one ever gets to go see. But come with me. It's COVID times. I need to wear my mask, but I'll show you around. Well, as we walk around, first I've just spared you not just a metal detector, but what is probably the longest and most substantial security checkpoint you'll ever find on planet Earth. But what is so interesting to me is what you see here. This is just a glimpse of the types of server computers that we find in room after room and building after building on these campuses. There are almost 500,000 of these server computers. They store as much data as you would find in more than 50,000 libraries of Congress. And I think that captures so well how this really is the infrastructure for almost everything that we're engaged in today. The way you live your life, the way you do your work, the way research and development are all moving forward. It all relies on this enormous amount of data and this enormous amount of computing power. So you just see here so much innovation all connecting together. But actually, that's not the end of the story. Come back outside and I'll show you one more really interesting piece. These campuses represent not only the most advanced digital infrastructure in the world, but some of the most advanced energy infrastructure as well. Why? Well, first, if we ever lose power from the electrical grid, we need to keep the computers running. There are more than 19,000 battery cells, each like the battery under the hood of your car, that will do just that. And at the same time that that happens, these big electrical generators will start operating as well. In fact, there's more than 140 of these generators on these campuses. Each of these will power the equivalent of 3,000 homes. The good news is with the latest advances in emissions technology, they actually give out less emission than a typical lawnmower you might use in your backyard. Each today runs on diesel fuel. In fact, there are tens of thousands of gallons of diesel fuel stored here, but not 10 years from now. We've said that by the end of this decade, each one of these needs to go. They'll be replaced by either new generators that run on hydrogen power or new advanced fuel cells. And in that, you see this extraordinary intersection between digital technology, energy technology, environmental science, and the need for innovation. This, in so many ways, is the physical embodiment of our mission to empower every person and every organization on the planet to achieve more.
So I don't know if you know who that was. That was, I think, Brad Smith, who was the former general counsel at Microsoft. And I think at the time he was president of Microsoft. I don't know if he's still president or not, but did a pretty good job for a lawyer talking about technology. So on this next slide,
It's an interesting choice to pick a lawyer to talk about technology.
well, you know, some of us have to. So on this next slide, AJ, can you tell us a little bit about how these data centers power our everyday lives and what kind of applications that are really at the crux of their existence?
Yeah. So if you're using your cell phone right now, you're using technology, you're using data centers, right? From when you wake up and check your email to taking pictures, exchanging documents, emails, looking up where the nearest Starbucks is, ordering your cup of coffee at Starbucks, online shopping, anywhere you interact with technology, you're using a data center because it requires compute, right? There's a server somewhere doing computation and sending you results back. When you take pictures, it gets stored online on a cloud storage that sits in one of those data centers. And you're not only just using data centers, when you use technology, you're actually enabling AI. You're generating a data point, right? As simple as how many steps I walked today. That gets stored, that gets trended, that gets fed into all the medical and healthcare research that we can utilize to improve humankind, right? So it's unless you've been living under a rock with no technology use, you are an active customer and consumer of data centers and technology.
So that explains why when I'm using Waze and I'm either driving too fast or there's too much latency where it tells me to take the next exit after I've already passed it.
Yeah.
You might have that experience.
Use Google Maps.
That was a gimme.
Not everyone knows that.
So yeah, it's hard to imagine today's life without data centers, right? And you saw we have upcoming slides and some data points on how the demand has exploded, right? With the advent of smartphones, right? Back in the day, you would generate data using only your computer when you're interacting with technology. With smartphones, now we're generating incredible amount of data. There's so many variables, right? We have smart glasses, smart watches. Each and every one of these devices is generating incredible amount of data and requires compute, right? They don't do their own compute. It just gets data from and information and compute from somewhere else. And those are the data centers. There's different types of data centers. Not all the computation happens in the one that you saw. Some of these are AI factories that we'll focus on. Some of these are edge data centers that sits closer to us, to the end consumer, so we can stream our shows and not miss a turn when we're driving around, right? Some of these are way back when you have to drive 50 miles out in the countryside, which is where the AI training is happening. So there's different types of data centers that we'll dig deeper into, but you know, we're our technology, our daily use of technology is what's driving the data centers.
So that's like where, when you're talking about AI data centers, the ones that are really remote are primarily used for training large language models where they don't need proximity to a metro area, right?
Yeah.
Whereas the AI data centers that are within close distance to a metropolitan area is done for the inference compute, which is how these AI applications process data and why they need to be close.
Yeah,
for
exactly,
latency
like
reasons.
storefront, right?
Yeah.
You have shelves where user can interact and grab an item, and then you have a warehouse where items are stored, right? So your storage could be in remote areas where real estate is not so expensive and power is available. It's hard to build a data center along the tollway anywhere, right? But we can have smaller edge sites that are more cost effective.
So Mark, why don't you talk us through some of the infrastructure developments of the past and where you see AI driving capital investment?
I think the president of Microsoft, I think in his presentation, did touch upon this a little bit. This is the foundation of the 21st century innovation. If you go to the 20th century, you've got similar build-up, similar infrastructure deployment in the past. I mean, a few examples that came to mind was the Trans-Alaska Pipeline, which was responsible for moving crude oil into all of our factories here in the U.S. The creation of the interstate highway system, the creation of bridges, ports, those were all examples of huge infrastructure programs sort of run by the government, costing billions of dollars, on which the innovation for that century was kind of built upon. The foundation layer of innovation in the 21st century, I think we want to call data center as that foundational layer, right? We talk about data centers, but there's been other examples of that infrastructure deployment. Fiber is one of the critical component for data centers. You've got massive fiber deployment across the country on which the data center industry is built upon. One of the reasons why you've got clusters around the country where data centers are built, Dallas, one of those clusters. You've got Northern Virginia, you've got Chicago, you've got California. It's because of the fiber infrastructure. And these are the investments done by the government in the past kind of led to the innovation. The difference is the scale of investment. I think the first time in human history we're seeing almost north of $500 billion of investment on infrastructure projects, right? Just the hyperscalers here, driving about $500 billion worth of capital investment in 2025. Like, that has no precedence in the past.
Okay. So can you talk a little bit about the power demand that these AI data centers have and how that's driving the strategy on this build out?
Sure. I think if there's one key takeaway from this discussion today, it is that the story of data center is the story of power. Without power, we've got no data centers. And the demand that we are going to see over the next few years is unprecedented. Today, we've got about 4%, 3.5% of the country's overall electricity used by data centers. That's going to scale up. We're looking at almost 10% of overall country's electricity used by the data center industry. Over the next 5 to 7 years, almost a fifth of the electricity growth can be attributed to the data center industry. That's unprecedented. And why are we seeing that? So if you see the need for the power in a rack, right? It's increased exponentially over the last multiple years. If you see the AI data centers, I mean, just the power consumed by AI data centers is leapfrogging the power consumed by traditional data centers, right? And why is it? It's because of the type of compute that is used for these workloads. The AI workloads is very different. NVIDIA is very different than your traditional Dell or HP. And that results in this macro level huge electricity and power demand. So overall, we're looking at about almost 1,000 terawatt hours of power being demanded by the data center industry over the next few years. I mean, take these numbers with a grain of salt. The story is that this is unprecedented. The amount of power demand that we've seen across the data center industry is a considerable bottleneck. And that's where a lot of innovation is happening on how to bring power to the data centers.
Yeah, I think that's an interesting aspect of all of this is, without the thing that I learned. So one of my clients built a AI data center project in West Texas, 1 gigawatt and sold it last year to a hyperscaler. And the interesting thing I learned is, that was only a powered land project. And so, not having been in the space before, it was quite an education on, well, why is there all this need for electricity? Why can't you just build a data center anywhere? And that was kind of my thought, well, there's a vacant lot over there. Why can't you put a data center there? It's like, well, because you can't just plug any location into the grid and suck a gigawatt of power out of it, right? Your grid has to have the infrastructure built to that particular site. And so that's a multi-year process with ERCOT to get them to commit to power a specific tract of land. And you have to go through these engineering studies and all that. So it's a long-winded process. But the interesting thing I learned is, because this data center was in West Texas, ranch land, farmland is, let's say it's, $20,000 an acre or $10,000 an acre. Very rural, out nowhere near civilization, right? Once you get the power commitment for like a gigawatt data center, it's no longer dollars per acre, it's hundreds of thousands of dollars per kilowatt of capacity you've secured, which is the powered land. So that raw land went from, let's say, $1 or $2 million to well over $100 million just by getting the power commitment. And the reason why everybody's having to plug into the grid is because it's hard to get on-site generation, right? Which is why you're seeing like Microsoft and others that are buying old nuclear reactors and plugging their data centers directly into them and bypassing the grid, because the grid's a bottleneck. And the whole energy capacity needs is where it's a choke point. And there's this huge demand, but for a long time, we've just been kind of percolating along, with the same level of energy needs. Appliances have gotten more energy efficient, right? So, but this has just been a huge spike up, right? So
you can't generate electricity overnight, right? To put things in perspective, Hoover Dam's capacity is 2 gigawatt. That's how much power it generates. And half of that is consumed by one data center, not the entire campus, right?
That's crazy. That's like
at one place.
Millions of households, right?
Yeah.
That's crazy. So Vince, why don't you talk a little bit about, data centers and their electricity consumption?
Yeah, so this graph here sort of shows the global picture, of what data centers' electric consumption is going to look like over time. These are the projections anyway. As you can see, out in 2030, it's projected that data centers will consume 3.7% of the power. So that's not a very large number compared to the total power that we're consuming, but it doesn't really tell the full picture, because as we mentioned earlier, you have data centers in particular locations or clusters. In Texas, for example, it's already at 4.6% of the power that's being consumed. 4.6% of all power is consumed by data centers. So, and it's projected to grow, especially as the data centers get built out, as you get more hyperscale AI-enabled data centers in here that are using a lot of power. It's going to continue to grow. Now, Texas is not as high as some other states. There's 6 states in the United States that are already using 10% of their entire electric power on data centers. And Virginia is using 25%. And that's a large amount of power. It obviously can affect the grid if you get sudden loads on the grid at any given moment. And so they have to plan for that to make sure they have precautions or technology in place to make sure that they can load it up properly. But at the end of the day, we've got to plan for the increased growth and demand on our grid systems and make sure that the data centers don't get ahead of us.
So Mark, can you talk a little bit about how data center construction compares to other major construction?
Yeah, I mean, if you see over the last 20 years, the overall electricity consumption has almost plateaued, right? I mean, it's kind of a straight line from 2000 to 2020. 40 years prior, there's been exponential growth because that's where the country was growing and there was economic prosperity. But over the last 20 years, by and large, our demand consumption is almost flat. And that changes. In November of 2022. Any guesses what was significant about November? It was ChatGPT, right? I mean, that's almost like a Sputnik moment for us in technology because, we're going to look at pre-GPT and post-GPT world. Everything changes in November of 2022. And one of the examples here is if you see, the graph says the data center construction after November of 2022 rapidly increased, but office building construction decreased. A lot of that is interest, right? But regardless, the need for power and the growth that we are seeing has been unprecedented. And this is coming from someone who's worked in hyperscalers. I've seen 40, 50, 60 megawatt worth of buildings being built in the past. We had, Google has a data center campus south of Dallas, 500 megawatts back in 2017 when it was being built. We were like, wow, 500 megawatts. Right now, 500 megawatts worth of campus are being built every other quarter, right? So even at the hyperscale, from a hyperscale's vantage point, I see this as unprecedented.
Yeah, I would agree with you. I think an interesting diagram there is how the office construction is going down as rapidly as data center construction is going up. But I think we're kind of in a unique market here in the North Texas area in that because you see, a lot of empty new office buildings that were built along the toll road, but they've been filling up because we keep attracting all these businesses from other states who want to come here for the business climate and the technology talent. So we're kind of I think a little different from the rest of the country. I have noticed office construction slowing a little bit here.
Absolutely. This is the new data center is the new, gold rush. This is the gold rush of the 21st century. I remember 2013, 2014, 2015, we were doing data center conferences and you would hardly see anyone from the real estate industry. Maybe one or two, smaller boutique real estate equity players who've had connections with the data center industry would come and inquire about data centers. I mean, today, look at this. I mean, Blackstone, KKR, every big real estate equity player has a massive allocation into the data center, digital infrastructure fund. So, I mean, we're a capitalistic society, and this is an embodiment of, us sort of chasing capital and, increasing data center construction and decrease in office construction is an embodiment of that, right?
And it is the gold rush, but not everybody's making money in the gold rush. And I think there have been some stories recently about these public data center companies that they haven't performed, met the expectations quite right. And I think part of that is because it is such a capital-intensive venture to build these data centers. I mean, look at the tour of the Microsoft facility, all the servers and all the infrastructure that goes into it. And so I think that even though there's insatiable demand for AI data centers, just because you're building one, it's not a guarantee of profit and success, right? And so I think that's what the market is kind of filtering out is there's some players that are doing better than others in that regard. But of course, the clear winner is NVIDIA because nobody, I mean, they have 85% of the GPU market, right? And they're making their money on their GPUs no matter who buys them and where they go, and now that they're able to sell them to China, right? So, so we'll be getting hopefully some tax relief since we're getting a cut of those sales. So Vince, why don't you talk to us a little bit about electricity generation for data centers and how you think we'll be meeting this power demand that they require.
Well, so, I mean, it's a nice graph. As you can see, there's a pretty large portion of the power that's being generated using natural gas. We have plenty of natural gas here in the U.S., and so it makes sense that that's what we're using. I think it's currently at about 40% of the power that is being generated is using natural gas. You can see that as we increase to 2030, it steadily goes up. But at that point in time, other forms of energy start to come online, including the small modular reactors that are expected to come in 2030. And so it starts taking up, a larger chunk of the power that's being generated. Also, wind and solar continue to grow according to these projections, although I think these projections were done before the tax credits were phased out. So that very well, you could see SMRs increase even more rapidly and wind and solar not as much because you still have tax credits related to SMRs. But the point is that we have a substantial increase in power needs over the next 5-10 years, and we're going to have to grow our resources in order to be able to supply that power.
And the challenge with AI data centers is that they need consistent 24/7, 365 power, right? They don't.
Yeah.
So some of these solutions like solar and wind, they only work when the sun's shining and the wind's blowing, right? So they can't necessarily supply all of the data center's needs, right?
Well, that's right. But you have, even though you're using solar and wind, you're going to still have, the natural gas power. Here in Texas, natural gas and wind are really the two sources. So if the wind's not blowing, you crank up the natural gas generators to take up the slack.
Yeah, so it's kind of like a multimodal type of electricity generation to power them.
I think most of the wind and solar is going to be behind the meter, but natural gas and the SMR, on-site generation is the need of the hour. Right? Today, you've got multiple, natural gas turbine companies, line up in data center conferences because they are the only game in town. That's the only source that you can use to generate on-site power. I think things will change over the next 10 years when the regulation and the stigma around reactors, small reactors, is going to go, and we're going to have the regulatory hurdles cleared to build small nuclear reactors. I think that will consistently be used because of the economics. Today, nothing beats the grid in terms of cost. Right?
Yeah.
But I think the only competition to the grid is nuclear, which is about 10 years.
Yeah. And on-site generation, right, beyond the capacity, it has an added advantage of not relying on distribution, which is a risk factor, right? You're generating wind 200 miles from here. You're transmitting, you're still relying on grid and that distribution infrastructure. I can generate a gigawatt more of power somewhere in Mississippi. I can't just consume it here day one.
Right.
But the strength that the natural gas generators and the SMR bring is I don't have the distribution risk. I'm generating on site. Right? My power is traveling less than half a mile to my compute where it's being consumed. Right. So that reduced risk plus lots of transmission. Right. I'm not losing anything. It's practically zero because I'm consuming where power is being generated.
But even on-site generation is not a quick fix, right? Because even though you're bypassing having to have the grid build out the infrastructure, which takes time because of supply chain issues, you can't just go into a warehouse and pick up a transformer and get it installed the next day, right? It's like there's huge lead times for all this infrastructure equipment. So if you try to bypass the grid and go on site, the same kind of issues apply for on-site generation. You know, these generators that can use natural gas or building a solar farm and things like that, they take time, right?
Yes.
There's not really a quick fix, which I think has been an interesting thing I've seen. I don't know if you guys have seen this, but a lot of the big tech companies were really focused on being green and energy neutral, but kind of after 2022 and this whole AI data center boom happened, they don't really talk about that anymore because really it's just they need power at all costs. This is like going to war, right? You need, and we're in a global race, right? Global race to win the AI race, right? And so that takes a back seat, and it's just been interesting because you don't hear people talking about it because they just need the power and they don't care where it comes from.
It's supply and demand, right? The innovation. We were talking with people in the audience here, right? If you're doing research and if you're developing a product, if you're developing technology that gives us a winning edge, right? We're not going to hold back because I don't have clean power, right? At the end of the day, if the customer wants to watch Netflix for 12 hours, we need to feed them.
Mm-hmm.
Right? You can't say, "I'll get back to you."
Yeah.
Or have a lag.
Or wait for a long download.
The other thing I was going to say is in terms of national security, if you distribute the grid, it actually changes the attack vector. Because right now, if you hit the electrical grid, you can take everything out in one swift move eventually after the generators fail, right? With the small nuclear reactors and whatnot, you mitigate that problem and create an array of targets.
So pretty much the whole country is a fair target now.
Yeah.
And a lot of these data center campuses are pretty easy to spot from satellites.
Yeah, right.
They kind of stick out, unless some of them are buried in mountains, old salt.
I wonder why they don't build data centers in Chernobyl. They should, right?
Yeah.
No, but the SMRs, right? The designs that I'm seeing, those are buried 100 feet under the ground, right? So those considerations are in play. Security, safety, away from any major population, dense location.
Speaking of security, I recall this was just after 9/11. I was doing some work for Walmart. I was flying up to their global headquarters every week, and they had a data center. Their corporate headquarters were in an old Walmart building. And I was convinced this is where all old office furniture goes to die. Nothing matched. I mean, they were really lean and mean. It's like, they'll pull out file cabinets and stuff. But in the parking lot, they had a data center there. And no security. You could just drive up into the parking lot, park next to the data center. And so they started building essentially a blast wall around it because they were recognizing that, well, if somebody pulled up a truck and blew it out, that because of the volume of transactions that data center processes, it would actually affect GDP if it went down. So, security is a big part of that, right? Which is why you see a lot of these data center campuses there's no name on the building, you have no idea whose it is, and even though it's kind of sticking out in the landscape like a sore thumb, they still try to maintain a low profile.
So we work with enterprise customers, of course, some hyperscalers. We have contracts with the United States Air Force and Marine Corps and Army. It's easier for me to get on Air Force Base than to get in a data center, right? I go through TSA pre. I don't have to take out my shoes, my belt. I cannot enter a data center without just practically stripping naked, right? It's insane how much security there is. I cannot take any electronic. I'm sure, Mark, you have the same experience with Google data centers, right? You got to take out all the metals. There's nothing that goes in. There's people who have pacemaker, and their security is 20 minutes to go through to enter the data center. And you always allocate that time.
So Mark, can you talk us through some of the data center capacity issues and how that's measured and where you see the most growth in data center capacity being?
Yeah, I alluded to clusters around the country, right? So data centers are built around the country in clusters. The largest cluster is Northern Virginia, about 4 gigawatts today, about 4.5 gigawatts. You've got Chicago, Dallas, California, some of the big clusters. I think what we are beginning to see is folks moving away from clusters, because in the past, building a data center was like a herd mentality, right? I mean, where are you going to build a data center? I'm going to go to Chicago or Dallas or Northern California, right? Because I already have the ecosystem. There was a long list of site selection criteria, right? And power was one item there. There was others. There's networking. There's access to talent. I think we were talking about building a data center in cornfields in Iowa. Good luck getting talent into the cornfields in Iowa, right? I think today that list has reduced to one line item: chase the power. If you've got power, you can't build a data center, and you are building a data center, which is why you're seeing a lot of these powered land deals around the country, right? Again, gold rush of the 21st century. I've got I was talking to an attorney a couple of days back in a conference, and he himself is working on about 30 to 40 powered land deals, which essentially means you've got someone who is having about 1,000 acres of land, and they are getting the contract from the utility to commit to the power. Once that contract is available, once the commitment is there from the utility, the cost of the land just shoots up, because now you've got land and you've got the commitment for the power from a local utility. And now Microsoft's going to chase you, and Google's going to chase you, and Meta is going to chase you, because you've just done their work.
I would agree with you. Like my client that's scoping out sites for their next projects, it's all about, they start with the power. What kind of power, what kind of capacity can I get? That's the single gating question for any potential site. And then if they can secure the right amount of power, then the next questions become, well, infrastructure, like how close are we to the fiber lines, and how far away is it? And, what, you can then start doing the math. Well, if it's $1 million a mile or 2 miles to build the fiber to the site, it might be worth it if you've got a 1 gigawatt capacity project, right? That's just a drop in the bucket. But
I'll give you an example. I was talking with a data center construction manager, right? Back in the day, in mid 2010s, right? They were going after, and before you buy, they'll do a soil survey. They'll figure out how the soil was. So if the soil was not good, not ideal for construction, they won't buy the land, right? And these days, that's not even a consideration, right? To your point, just get me power. I'll dig 50 feet down, right, and build up. I'll bring my base, my foundation. I don't even care about soil quality. What's down there doesn't matter.
What you see on the right-hand side is comparison of the amount of data center construction, from over the last 5 years, almost 6x. The other thing to note here is Northern Virginia is the data center capital of the world. 4.5 gigawatts. There's no other city on planet Earth that has that many amount of data centers built and that amount of data center capacity consumed. Northern Virginia data center business or industry was built over the last 40 years. It took them 40 years to go to 4.5 gigawatt. In 2025, there is construction of 5 gigawatts of data center capacity. So we're building one Northern Virginia every year, starting 2025, moving forward, and it's not going to stop. So imagine 40 years spent to reach 4.5 gigawatt versus 1 year, 5 gigawatts. Mm-hmm. Of course, it's not in one specific city or one construction overall, but I think that gives you sort of an idea of what's coming. And we are in the infancy of the AI age. This is like, the other day I was telling someone who was complaining about, Grok or GPT hallucinating and saying this is never going to fly because look at the answer, right? I'm like, okay, did you complain about your website not being fast in 1999? How long did it take for your website to load? Right?
Or dial-up modem, right?
Yeah, modem, right?
AOL just is cutting off the dial-up service.
This is 1999. So
I think they've got some auto-pay customers that are still paying for dial-up that don't know it.
How do you forecast such a huge demand of energy from the data centers? What is the driver right now to forecast that?
The driver is, you using ChatGPT. Everyone's using ChatGPT. Everyone's using AI for their use. I mean, I look at AI as fundamental to our existence. Every business and every function of the business is going to fundamentally change because of AI. That has never been in the past. 2020 was bringing everyone online, right? I mean, there was an aspect of bringing everyone online, but the sales department, the HR department, and other functions did not gain in 2020 because there was nothing for them. Today, we are at a crossroads where every company and every function within every company will change. That's the reason for the growth.
And so you have the consumer growth on one side, right? Then there's the government support for AI data centers, right? Which is what's driving a lot of businesses. And then the data center life cycle, if you build a data center, it's anywhere from 2 to 3 years. So we know what we're bringing online 3 years from now, 2027, 2020. And then the hyperscalers, especially, they're forecasting their 5-year, 10-year growth plan. So if you listen into the earnings call and the quarterly call and yearly calls for any major hyperscalers, right? They're talking about what they're building. Google is as well, right? Most hyperscalers, the data centers that are being built today were designed in 2022, 23. So what we're designing today are going live in 2028, 29, 30. And I know the capacity of those data centers. That's how we're able to forecast pretty much accurately next 5 years at least. Unless something like a ChatGPT hit, and that changes everything, right? But normally, we have revenue forecasts from our customers, and we have labor forecasts, right? We have designs, we have the utility contracts that we're working on. Those are not signed today, right? I signed up for a contract for a demand, and the utility has to build my substation, my powerhouse. So that's 5 years is normally, we get pretty clean 20 by 20 visibility.
So it's basically demand forecasting, which
Yes.
starts with kind of the apps that are generating
Yeah.
the users, which then generate the demand for the GPUs. And, I've heard various stories about how long the waiting lists are just to get an NVIDIA GPU
Absolutely.
for even the hyperscalers. So they've already pre-sold a lot of supply for GPUs, data center capacity, years out, right? So it's definitely not a hype, but I think it's more just it's a game of trying to keep up with the demand. It's insatiable. It's like nothing we've seen before, right?
Yeah.
It's not like when companies went online to sell furniture on the internet and stuff like that, around 2000 with the internet boom, right?
I mean, we haven't even spoken about 2 killer use cases, right? I think, Paloma, you asked, like, it's good to be skeptic about this, right? Where is this demand coming from? I don't see the demand, right? And that's a very valid conversation. But let me ask you this. You drove here today, right? I'm assuming you're driving everywhere. I can guarantee you in the next 5 years, you are going to sit in the back seat of your car and the robot is going to drive itself, right? You're doing your chores today in your house, right? I can guarantee you in the next 7 years, there's going to be a robot that's going to do your laundry and your dishes and everything in the house, right? So that's the demand for, so we need data centers so that the robot can do your laundry and your dishes and the car can drive itself around, right? So that's the demand
I
story.
know we're talking about the demand of the data center, the electricity of demanded by the data center. But the flip side of it is, will it impact consumer like us? Because there's so much demand on data center side, and our electricity bill will keep going up.
That's
So
already a concern,
how-
and that is, water bills
Government
and
or policymakers, and even though our business owners, business investors, how do you balance this, the concerns on the consumer side versus the demand of the data center?
I mean,
So-
that's a very valid concern. I think there was recently one of Amazon's projected data center deals got canceled in Tucson, Arizona, because the community came and they did not want a data center in their backyard. I mean, for whatever reason, right? So that's a very valid concern. I mean, regulation has to be involved there.
I think there's one disconnect between some people. They don't understand that the data centers, why are they consuming so much power? that your ChatGPT that you send goes to the server, which requires a lot of energy to process your prompt. And then that's where the energy demand comes from. The NVIDIA chips that they use requires a lot of energy. And that's why the data center requires a lot of energy. It is not the consumer who pays this electricity bill. We are simply sending a request as a client. But the server who's processing it requires a lot of power to process that request. So earlier she had asked a question, I think that's where you were. Why do the data centers require so much power? Because they have high capacity, high energy consuming servers.
Good question.
It's also because the AI right now doesn't actually learn, it's trained. There's a distinction to be made between an AI learning and an AI being trained. If you have to be trained, you're not learning like a human, you're not going to be efficient. So in order to learn what a stop sign is, if you have to look at a green, red, blue stop sign, then understand what a square, circle, and triangle are in order to get to, okay, this red sign is a stop sign, you're burning up all of that power in that process, if that makes sense.
Well, I think in part of the problem also is that the enterprises that are paying for these tokens and the LLM use, they're not actually paying the full cost of it, right? A lot of it is being subsidized. So they're not paying the full energy cost, but on consumers, it's, when there's energy demand and there's not enough to go around, prices go up. That's why natural gas was on your chart 40% for so long of energy generation, because natural gas has been cheap. So you try to find, but natural gas prices are probably going to go up too, because it's now got more demand. Anything that's going to generate energy is going to, so we're probably going to see prices go up. So Vince,
you mentioned about the projections in the next 3 to 5 years, the energy consumption is going to go up, and the data center construction is all going up. But it's also a fact that you mentioned, and we have all seen, every industry is being impacted by AI. Don't you see that there could be some breakthrough in energy generation, energy consumption of all these large language models? Wouldn't you envision or even predict that we might have better models which do not need this amount of energy in the next 3 to 5 years? It's a long way, and the amount of breakthroughs that we are making with AI, it's significant, very significant. Significant is probably a small word to describe what it can do. So do you see any of that?
Absolutely. I mean, I can't keep up with the AI news. Like every day there's something new, right? I mean, last week they came up with the OpenAI came up with its first open source model, and a few days later they came up with their GPT-5, and then Google came up with this small language model. I mean, it's changing at a rapid pace, and that what you're saying makes a lot of sense. What if DeepSeek was real, right? I mean, what if they actually were able to train, as they claimed, 100th of the cost of training, right? What if that's real? I don't see that reducing the demand, because if the model becomes more efficient and training becomes cheaper, more and more people are going to do that, right? Yeah. So the friction to enter is going to be lower. So then everybody is going to train, right? So.
Well, it's kind of like what we've seen with technology and compute generally, where we went from single core to multi-core chips, and so as computers have more power, then the applications that are built off of them, require more memory and more processing power. And I think the same thing with AI. And one of my clients does small language models, and what they were saying is that, it works for things that are not complex on the small footprint, but the more complex your process is that you want to outsource to an LLM, the more compute it requires, which means that it can't be local. It's got to go out to the cloud, to these large language models, which use a lot of electricity. So as the efficiency of these GPUs gets better on energy, it's kind of like a vicious cycle where they become more efficient, but because they're more efficient and more powerful, then apps can be built that are more complex, which just consume more and more processing capacity and power needs, right?
I think the adoption curve increases as the friction to entry and the cost reduces, right? I think the adoption curve is the
Yeah, I don't think we're going to have excess capacity sitting there, right? If the cost decreases, we're just gonna see more and more use cases.
Is there a reason that Northern Virginia has so much capacity? Like, is there any specific reason for that?
So the demand is the main driver, right? That's where the federal government is located. That's where most of the customers, the initial first customers were, and it just traditionally has been there.
Takes a lot
And
of
the
power for people
fiber
to
network.
Watch you 24/7.
And the fiber network was around the Capitol.
Does anybody have an idea of how much power it takes per user? Like, just frame of reference, I need 2,000 kilowatts for my home and my AC and all that. How much, I mean, would I just give a ballpark? Like, how much per user are we talking about? Like, is it the equivalent of a Walkman, or is it the equivalent of me, like, carrying, 50 amp woofer with me? Or like, how much power per person are we stacking on top of our resistance here?
I'm not sure I could understand what.
The question is there a number, like not per user, but I know there's been
Average power used per user is what he's trying
But
to get,
query.
but it depends on complexity of queries.
Yeah, I think he's talking about not user, but queries, right? I mean, so I think Google did have, I think it was 2 cents, not power, but we did in a number, ran the numbers, and it was, I think when I was at eBay, we did the number per transaction, the cost for the transaction was 2 cents. I mean, I don't think someone has that answer, in terms of queries for LLMs, because each query is so different, number of tokens, the complexity. So
each time I ask Grok something easy or difficult, they've got the fast, they've got the think deep. So each time I like think deep and I wait 60 seconds to get my answer, I'm paying $16 a month, but they have a cost of X. That's another way to ask my question.
yeah.
Yeah, so in other words,
That's what
I'm trying to get
that's
at.
a training
we
person.
pay subscription like $20 per month right now for ChatGPT Plus. How much of that would be attributed because of power consumption? Like, so any percentage? Like what I pay like a monthly subscription for ChatGPT Plus, let's say $20. How much of that is actually attributed towards power? Any?
I don't have an answer for that.
They don't hallucinate, I'm sure.
This one is one more question.
Because there are industry experts, and normally in the IT technology before, for example, IBM, gigantic machines, and now becomes PC, becomes decentralized, and then goes to mobile. And do you see those data centers going to be the same way? I mean, it's gonna be from like gigantic system and into each communities, and then eventually goes to each houses.
I mean, we already have a flavor of that, where you've got the huge AI data center is a recent phenomenon, right? I mean, you've had data centers that were in the middle of nowhere, like the cornfields of Iowa, and then you had edge centers, which were maybe in Plano or Frisco, right? The difference is the hub would be a 30 megawatt cluster versus the edge, which would be a 5 or a 4 megawatt cluster. So we had that flavor. Can that further be decentralized and put in my bedroom? Probably not. We'll have to see.
But there are the edge data centers, right? So the big ones we're all in agreement with, right? There's edge data centers at every single cell tower. So if you go drive past a 5G cell tower, you'll see a small, like half a semi-truck size of cabinet, and that has compute in it, right? There's also, for those of you who use Apple, they manufacture their own chips, and those are AI enabled, right? They're not doing compute, but they are ready to do inference, which is where they can enable that AI close to you, right? There's a lot of AI enabled devices that's bringing not the entire data center, but intelligence and smartness close to you. Funny enough, I saw a AI enabled toothbrush advertisement. It is real, right? You have AI enabled all type of devices, and it's chips. They're not doing any of the training or inference, right? They're not doing compute, but they're just ready to consume what these big data centers at 50 miles from you are ready to send you. because our traditional chips are not capable of doing that. They just know the basic 0 and 1 binary, right? They can just process basic data, not AI enabled inference that comes to you, right? So that distribution is in place. That is part of the architecture.
Yeah.
That's how we are able to deliver to the end user.
Thank you.
I think we can move on. There
Yeah.
are more interesting slides.
Yeah,
coming.
yeah,
We're
yeah.
going to break the data center show. I think we can move
We'll have
on.
some time for Q&A later. So.
I mean, this is a capacity story.
Yeah.
Overall, 125 gigawatt data center capacity in the globe. US is number one, about 50, gigawatts. Europe is another cluster. China is coming up big. Singapore and now Malaysia around Singapore is also big clusters. But this kind of gives the overall picture.
Yeah.
You can move on.
Okay, so this is one of my favorite slides, right? When you look at a data center, what is it? From the outside, it looks no different than this building. But when you look at a data center, it's going to host computers, right? Computers need power. When you feed them power, they run, they compute, and they generate heat. So to negate that heat, you need some sort of cooling. So this slide explains, and this talks about how a data center is actually structured. First thing, you have utility power landing in. I'm going to move around. So you normally have 2 feeds landing in from 2 different substations. So if one side fails, you still have power. And then there's backup power generation. This is what we talked about a lot. It could be natural gas, could be diesel, but there is ability to actually generate on-site power right now at almost every single data center, right? Then you have redundant feeds. So each rack is fed at least 2 separate feeds. So if one side fails, the second side will continue keeping the servers up and running. So two feeds feed the rack. The rack has server, compute, or storage, one of the 3 types of load in it, right? And as I said, when you run these servers, they're generating heat. To negate that heat, we need to cool the data center. It's traditionally been done using cold air, just like how we are cooled here, right? You'll just supply a lot of air-conditioned cold air at whatever supply temperature you choose. Anywhere back in the day, it used to be 50-something degrees. Right now, we're running at 90-something degrees and still fine. So the IT equipment that goes in the racks is also advancing to run hotter and hotter. But to generate that cooling, we have cooling towers where these are evaporative cooling towers normally. And you have cold air, water just dropping down, and heat gets absorbed running through chillers. The other important aspect, so we talked about the physical space where the data center sits. We talked about power and cooling. The fourth important aspect of a data center is networking, right? If I need to interact with the outside world, the data center by itself doesn't do anything. So a data center would normally have a networking room. We call it meet-me room is a technical term, where the data center meets the outside world. That's where the internet comes in. Traditionally, those have been switching facilities, if you will, right? It's just connect one network to the other. The AI is putting a lot more demand on it. Mark's going to talk about what that network is, but and security, of course, we talked about this. There's perimeter security, very, very strict access control. One interesting thing about data centers is these massive facilities don't need a lot of people to run them, right? You can run with minimum staff because the systems are built to not fail. It runs automatically, autonomously almost. You need maybe 3 to 5 people to just run a data center day in, day out.
And that's the basic data center. So the next slide's about AI data centers and what's different with those.
Yeah. So that's your traditional data centers that we've been building so far. The AI data centers, right? The main difference is the compute, right? The load that goes in. When you look at a traditional server, it's this thick, right? Probably consumes 100 kW or 10, 12 kW in worst case. And now we're building purpose-built data centers for AI. And these are what we call hyperscale data centers, right? So some examples, Stargate, which is in West Texas. Microsoft is building Google, Meta, Amazon, Oracle, any big compute technology provider that you talk about, they're building hyperscale data centers. And these are hundreds of megawatts, if not gigawatts of campuses, right? Built to support AI load. to support the GPUs, the NVIDIA GPUs, and every other kind that is being built right now. Very, very high rack density. So the traditional data center that we saw was from 2 or 3 kW per rack to maybe 25, 30 kW per rack if you're pushing it. The hyperscalers are 40, 50 to 100 plus kW per rack. And the power distribution technology, the cooling technology, the security, the architecture, the design, everything is different. We're not building those data centers alike. If you talk about, back in the day, the CPU-centric computing, which is the traditional data center, to what is what goes in an AI-enabled data center, right? So the CPU-focused servers, which you would have traditionally seen, like looks like a pizza box, those are no longer. They cannot support the AI workload, right? So now we're deploying GPUs. They look and feel different. They're cooled differently. They're built differently. As I said, the traditional data centers were 5 to 10 kW per rack. That was the max we would deploy. And the AI data centers, I think 40, 50 is where you begin. That's your IT load, right? That's the rack density. The AI data centers are also pods, right? They're not deployed in racks, but you actually have a collection of, it's almost a modular data center, if you will, right? You have one small pod that gets deployed, then you deploy multiples of pods, not racks. The traditional data centers were cooled using forced air. Like if you walk in, it's very high airflow, colder temperature that could not be utilized for these high density racks because of how much heat they're generating, right? The GPUs would literally melt. That's how hot these data centers run. So liquid cooling is not optional, but it's mandatory, and we're going to get deeper into the liquid cooling solutions.
So as far as power distribution, how is AI changing the strategy on that?
Yeah, so this is a representation of a traditional data center right now. Up here is our electrical room. This is normally called gray area, right? This is my white space and gray space. White space is where IT load is. So traditionally we had, again, our electrical room, switchgear, transformer, UPSs, batteries, everything. And we're drawing circuits that feed the rack, right? So if a rack has 5 servers, I'll feed whatever 60 amp circuit to the rack and then power everything that goes in that rack. That's how we've traditionally dealt. And if you pay attention, in this example, we had 160 square foot of space powering all of this IT load. And in the next slide, we'll show you how it gets consolidated into 32 square foot. 20% space utilization delivering me the same IT capacity, right? It's very condensed. It's very, very powerful. So that's where the space consideration almost goes away, right? I don't need much space. I care about power. Give me power. I will build multi-story data centers for that care, right? We've seen 3, 4, 5-story data centers being built because space is an easier problem for me to solve. Network is an easier problem for us to solve. Cooling is almost solved with what we're going to show, but power, again, it's absolutely critical. So this right here, again, it sums up what we're trying to show in last 3 slides. In a traditional model, which is on the left-hand side, you have grid, you have a UPS, which is uninterrupted power supply. So it has a bunch of batteries and it kind of carries the load for a few seconds in case there is an outage. It also cleans and conditions the power. That's the function of the UPS. Goes through a power distribution unit, which is a step-down transformer, really. And that's how we used to feed a rack, right? This is very monolithic. There's multiple points of failure. There's multiple conversion, right? The power comes in, the switchgear gets conditioned, goes, and this distribution loses not significant, but considerable amount of power. With the new AI-enabled or AI purpose-built data centers, right? We're feeding DC power directly to the rack. The rack has its own CDU because I cannot just run my cold water loop and cool it at the edge of the facility or perimeter. We're supplying DC. This example talks about 800 volt DC direct supply to the rack. We're seeing a megawatt racks coming out right now. Those are ready for production use, right? So this is actually this is what we're building for right now.
So is the idea that basically you're eliminating the single point of failure, like that Microsoft data center with 500,000 servers? The data center doesn't go out if one of the central parts fails. Every rack basically is a self-contained operating unit. So, if a rack goes out, it doesn't take out the rest of the data center.
Exactly. Yep. And maintenance and operations, right? It makes things so much easier. Right now, we struggle with this is if I have to bring down, if one of the PDUs go down, I have to bring down the entire UPS. I have to notify hundreds of people and saying their IT load may get impacted. With the modular, I'm just impacting what's in my scope, one rack. Right? That rack is giant, of course, the size of an almost data center, but yes, the modularity is a big strength.
But of course, if you're plugged into the grid though, and you still have only 2 transformers serving the data center, or if you only have one, if the transformer goes down, it takes out the whole data center. So you still do have some single point of failure.
Yes.
Potentially, but at least this is mitigating some of that risk.
Within the building itself.
Traditionally, there are 2 feeds coming into the data center. Ideally, 2 utilities. So utility A fails, utility B is there.
And you also have the backup generators too that will kick online if you had a failure.
Yeah. Rarely we lose a data center where there's no power. There's so much redundancy built in. The generators get tested on a monthly basis. We have load banking. So we don't lose it in that term. But for us, if I have 3 sources and I lose one, that's an escalation because just in case, right? Our contracts are written in terms of 9, so my availability is 99.99999, right? We talk in terms of 3 nines, 4 nines, 5 nines. That means I can only lose to be offline. I can only afford to be offline a few seconds a year, right? Anything beyond that it's going to bring my business down, right? There's use cases and case studies of actually data centers who did not comply and they go belly up. You can't keep up.
And coming from the technology world before Gen AI, that was one thing I was always familiar with was, the 5 nines of reliability, right, with systems and stuff. So when I first started delving into, assessing use cases and solutions, when I would ask about the accuracy and they would say, well, it's 70% accurate or 80, I'm thinking, well, that's not fit for prime time, but, so that's I guess in the AI ecosystem, that's the one exception to the 5 nines is the accuracy, right?
Yeah. And we're getting there, right? To Mark's point, we're in the 1990s for where the internet was.
So let's see. Did we talk about this?
I think we covered.
Yeah, we covered everything in here.
Cooling the beast.
All right, cooling. That is Mark's favorite topic.
I think we did speak about cooling, but why is cooling such a big deal? Right? I mean, I'm sure you're using your cell phone. If you keep using your cell phone for a couple of hours, does it heat up a little bit? Laptops heat up, right? Imagine the same thing happening in data center. It's nothing different. It's the same thing. Your servers running constantly and generating this heat. That heat needs to be rejected. Else the servers come down. Traditionally, when I say traditionally, I'm talking about the last 20 years, right? The mainframe era did have liquid cooling. So we are kind of taking, the full circle into the future. We did have in the 60s and the 70s mainframes that were cooled using liquid. But for the most part, over the last 20 years, we've used air cooling in data centers because the rack densities was somewhere lower than 20 kilowatt. And lower than 20 kilowatt worth of rack capacity can easily be cooled using air. But as we've begun to see densities increasing, and the NVIDIAs and the AMDs, the thermal TDP, they say the amount of heat that a chip generates as those started increasing, we had a problem in the data center industry because we were not ready to cool these servers. And 2014, 2015, 2016, we've begun to start about we were beginning to start about talking about liquid in the data centers, right? But this was completely different than what data centers were built for in the last 15 years, because liquid in water, you need to protect the data center from liquid and water damages. But then, over the next 5-6 years, the discussion was around how do we reject the heat using liquid, right? So there were operational challenges. There were a lot of concerns around bringing liquid into the rack space. So there were multiple types of liquid cooling designs that have been discussed. The most common today is what we are calling D2C, which is direct to chip. So you imagine a server where there's two feeds, a pipe that takes a liquid to the chip where the heat is generated. The heat is rejected at that source, and then the source, the warm water is then taken out of the server using the same pipe. And then at the end of the row, there is a CDU that rejects that heat and takes it outside the data center using another liquid loop. So there are two liquid loops, one that rejects heat from the server, takes it to the end of the row, and then the second liquid loop that takes that heat from end of the server to outside the data center. So that's direct to chip cooling. That solves the problem for the most part today. But as we begin to see power density increase to 100, 120 kilowatts, direct to chip is also not going to be sufficient. So that's where we are, thinking about having a full immersion system where imagine a tub of dielectric where the servers are immersed into it. And that's sort of the future of liquid cooling. I think we have a couple of videos that we want to show.
Sorry, I recently read an article where China deployed, I think, a data center under the ocean. Do you think in the future that's feasible for America?
I think we already have. We started it.
Microsoft has already done it.
Yeah.
Oh.
Yeah, Microsoft has a proof of concept where they inserted a data center. I mean, when we say data center, it's really a data pod. It's not really like a megawatt worth of data center being deployed in the ocean, but they inserted a pod inside the ocean. So we've already done that. I don't know what was exactly done in China, but is there a scope of building data centers in the ocean? I think there was another proof of concept. There was a data center called Nautilus, which was built on a barge on the coast of California. So people have been toying with the idea of building data centers close to the ocean so that heat rejections is easier and cheaper. But the question today is power, right? That's the fundamental question. I think
there was also somebody testing with building data centers in space as well. So the podcast really recently, they're just trying to build there to keep it cool.
Cool. Well, there's also some discussion about using the heat that's rejected from data centers for some other purpose, like, I don't know, an industrial process that needs heat. If you can put the data center by that refinery or whatever it is that might need the heat, then you can reuse the heat that's being generated. Have you heard of?
There have been a couple of use cases in the Nordic countries where the heat generated from the data center has been used primarily for heating residential.
Mm-hmm. So here's a video on liquid cooling. There's no audio in this one.
Yeah, we don't want the audio. It's just the video we're going to talk to. So this is the two pipes that I spoke about. So this is the chip where the heat is generated. You're going to see two feeds into the chip.
So the tubes that you see, right, the red and green, that's actually transferring cold liquid onto the chip and then bringing out the hot out.
So
This is much,
around the chip, it's not really immersed into the chip, right?
it is not.
The water doesn't.
Correct. The next one is.
Next one.
Yeah.
The first one is not.
Well, I mean, so the chip is contained within, it's a metal casing. The liquid is flowing through the metal casing. The heat's rejected from the chip into the liquid, which flows through the metal casing. The rest of the server is dry. The liquid doesn't immerse it. What we're seeing right now, what we will see right now is the entire server being immersed in the dielectric.
Not salt water, right?
No, dielectric.
And this, of course, is the most effective way to cool anything, right? When you get.
Yeah.
Is it mineral oil?
This is mineral oil. I mean, yeah.
There must be a closed loop system to recycle.
Yes, that's exactly what it is. Yeah, two-phase. So the water, the liquid gets hot, evaporates, condenses. A little difficult to manage, gets messy, but this has been done today. This is the future.
Lots of innovation there.
Yeah. I mean, this is against everything that we did for 15 years. Keep liquid away. Keep liquid water away from the data center, right? Yeah, and then the two other components, networking and storage. There's been innovation in the networking space as well. The more the bandwidth and the latency requirement, the bandwidth's getting higher and the latency needs to be lowered. So there needs to be a lot of innovation in the interconnect technology, which is a fancy way of saying, you have a nice fiber that goes into the server so that the data can exchange from the server to the outside world. There's a lot of innovation in that space, and also in the storage space. There's a lot of innovation in the AI data centers. If you look at the graph, you're seeing that the network bandwidth and the power density kind of increases in tandem. Where are we going the road ahead? Some of the challenges, I think a few concerns were brought. The biggest challenge, I think we've spoken about it in the power sourcing. Power is a big challenge. Very expensive, high capex cost. The last I knew, a megawatt worth of data center, costs around $12 million. So you're looking at more than $1 billion just to build 100 megawatt worth of data centers. And today's need is not 100 megawatts, 10x those, right? So it's very expensive. Cooling's difficult. And then community, right? I mean, gave the example of Amazon's projects being canceled in Tucson, right? The community is now coming up to the fact that these warehouses that was quietly being approved are not really warehouses, but these are data centers that makes that makes your electricity consumption go high. There's a lot of water consumption, so there's a lot of opposition. So we'll deal with that. I think in terms of future technology, I think the one that I'm very interested in and spending most of my time is how do we use the intelligence that we're producing in these data centers to make the data centers more efficient, something that you were alluding to, right? Can we make our compute more efficient? Can we consume less power? I think those are some of the future technology that we're focusing on. And I think key takeaways, I think mostly is there is going to be a lot of power consumption, and this is the next golden rush, the gold rush.
I have a question for you guys. Are y'all working with any other countries? Because I know there's a lot of money flooding in right now from like UAE, Saudi Arabia, Japan, South Korea. I was just wondering if y'all are also working with those countries in building data centers, because I know it's one of the initiatives there.
Are you talking specifically about Saudi or just in other countries?
General.
Yeah, data centers are going to be required wherever there are humans. Every country needs data centers. Yeah. Because the training can be done away from human population, but the inference needs to happen closer.
Yeah, no, I was just asking, so y'all are working on data centers over there and stuff too? Like specifically y'all, I guess is what I'm asking.
So
We work with every company, yes,
Okay.
every country, yes.
There are data centers being built in that region, and there is definitely money flowing in from all over the place, right? There's almost every real estate and energy player is in data centers right now.
Gotcha.
We used to go to conferences and work with only data center people. Now there's every other person is from energy or real estate.
Well, it's interesting how all of the many disciplines that are required to bring a data center project to life. My client has energy, power generation experience, real estate, data center, all these compute, telecom. And so he works on, he went from one desert to another. So his West Texas project, he's got now a project in Dubai, because Dubai is building, they want to be the center of all things technology, and they're putting a lot of money into technology and AI specifically. So they're building some massive data center projects as well, both for probably, the LLM creation and training, as well as, inference, because they really believe in kind of being technology advanced as a society. And I think they're building one of those hyperloops to connect Dubai and Abu Dhabi and
I mean, this is going back to your question, right? I mean, this is a national imperative, right? Every sovereign government wants to be the number one in AI, for whatever reasons, right? I mean, you're going to see the next type wars being fought through the drones and the robots, right? The foundation of all of that is data centers. So, yeah, every country is very, very interested now in having their own sovereign AI and therefore sovereign data centers.
So we obviously know that we need a lot of power, right? So what are the alternative sources of power that I know I saw something like fuel cells? So are there any projections like how we're going to meet the demand of these data centers?
There are multiple, alternate sources, right? The most interesting one that I, seen or heard is Bloom Energy, which is producing electricity from silicon dioxide, sand, essentially. There are other forms of, energy. You've got, natural gas is the most promising. Nuclear is sort of the most efficient from a cost standpoint, but it is very difficult to get the regulations around nuclear. Solar and wind, not really, but solar and wind is a good behind the meter sources.
Geothermal.
Geothermal is another one I was
Follow-up
going to
question. So
mention.
do you think that each data center when they build, they also have their own source of power generated locally within the data center itself?
Yes. I think the gas turbines, natural gas turbines, right? You can install a natural gas turbine on your campus today and generate your own power. You can technically have a solar farm or a wind farm close to your data centers, but that's not really a very, very consistent source of energy. So most of those solar and wind energy is kind of behind the meter. I think we had one more question.
Yeah, no, I had a question from like an enterprise demand standpoint. Like, are you seeing businesses and enterprises kind of snapping up the demand because it exists now and it takes time for it to build out? And is that driving a lot of the demand of the existing capacity? Or are you seeing businesses kind of projecting into the future and saying, okay, I know that 5 years from now, I'm going to have these really amazing use cases and, I'm going to purchase the capacity now and wait and use it later? What are you seeing in the space?
I think it's a little bit of both. So there is going to be huge demand in the future. So let me get the land and the power now so that I can build data centers over the next 2 years so that I can use it 4 years from now. So there's that. And then, there is immediate need for the compute. The last I heard, the balance sheet of Google Cloud and AWS and Microsoft's doing really good, right? And thanks to the cloud demand. So.
Yeah. And even in the traditional data center capacity, which we call co-location, right? If I need, let's say, 500 kW of power, right? That is, I will get there in 5 years, but I need to secure that right now because if I don't do it, somebody else will is going to take that space, take that power, and I have no room for expansion.
And you can't wait till you realize you need more
Right.
capacity, because
Yeah.
by then it's too late, because it's gonna take 3 to 5 years to build it out.
So they're good paying for overcapacity and overprovisioning right now.
This
as a
happens
current
all the time.
investment.
Yeah, that's a different business model,
Well,
though, right?
there's,
I don't think
well,
you can sit
you're
in
not,
idle.
you're hitting into a very good, interesting, nuanced point, right? I mean, you can get the capacity, but you don't have to pay because there is a ramp for the capacity. So today, I can go to a colo and say my overall consumption is going to be, let's say, 40 kilowatt. But I'm going to start with 10 kilowatt, and I'm going to grow into 40 over the next 4 quarters.
And you can secure, right? You can have first right of way, so you can write in your contract, I'll pay you extra before you give this space, this power to
So
anybody.
it's like on reserve.
Yeah.
On
And it's
reserve.
built into your pricing model.
Yes.
Exactly, yeah. So you don't use it, you lose it, but
Right.
you still have the right to that.
Based on that and kind of just the prohibitive costs of construction in this space, right? Do you, this is totally conjecture, but do you expect to see like a consolidation of companies that are in this space? Like similar to like what we saw with social media, right? Where it's like at first there was like lots of little startups, they acquired all the small companies, and now we really only have a few really major players. Do you expect that same consolidation to happen here, or? do you
I think that's
it's-
already happening. That has happened over the last 5 to 7 years, where there has been a massive consolidation of small data centers here and there. I mean, the exit multiples for data centers in 2016, 2017 was almost 20 times EBITDA, 25 times EBITDA. That's unheard of in the hardware business, right? This is not software we're talking about. This is like physical business, right? So a lot of people made a ton of money. They went on their vacation, bought their yachts in Miami, but they came back again because now they're seeing gold rush 2.0, right? I've got multiple examples of people who are like not to be seen in the data center space, coming back again. Well, here I am, I'm going to do this again.
So the
Let's make
field
some
is,
money, show me the money.
I need another yacht.
the field is so hot, right? Even with consolidation, you see new players coming out every single day. Some are region focused, right? Some are focused on verticals. A data center requirement for a healthcare company is different than financial institutions, right?
Right.
So you're seeing data centers that are purpose built for industry, for domains, for regions and markets. There are data centers that will build only in Texas. If I find 1,000 acres of land and a gigawatt of power, I'll build a data center. The consolidation doesn't decrease the competition or smaller players, right? There are, again, niche players who focus on only hyperscalers, only social media, I know data centers that only sell to Meta, for example. That's the only customer. And they'll go build in any market, cater to that one customer and still be happy.
So are you seeing companies like that looking into buying small data center players? And is Meta building its own AI data centers?
Yes.
The way Microsoft is, the
Yes.
way like
Yeah.
people are building their own chips and getting
Yes.
into business on their own.
So AI is the new, right? That's the hotspot. That's one player. Businesses still have the legacy infrastructure, legacy code, legacy applications. That's not going away, right? AI is not replacing how Google search works, right? So that infrastructure is still there. They're building AI, but at the same time, like I was just telling Vincent, right? So this week I submitted proposals for a 150 megawatt of traditional data center, not AI, air cooled, 50 rows, whatever, 100 racks each row, right? So 5,000 racks of traditional 30 kW is the capacity that I have. Those are not going away, right? That's a different use case, different model, different market.
Yeah.
Yeah, Meta is actually pretty heavily involved in research and development related to data centers, and in fact have devoted a lot of their intellectual property to modular type designs so that it makes it easier for them to build data centers because they can get standard parts and that kind of thing.
And there's going to be massive innovation in this space because now players like Meta and Tesla are now building their own clusters. To answer your question, Meta was always one of the largest data center builders, along with Microsoft, Amazon, and Google. They always had their own data centers, and now they're just doubling into that. right? They're building data centers in the tent. They're building data centers with wood, unheard of in the industry. Kind of goes to what you're saying, innovation, right? I mean, yeah.
When they clean out Alligator Alley, then, or Alcatraz, where they can just move right in those tents and put in racks, right?
Well, I mean, interestingly, the first infrastructure announcement by President Trump was, guess what, a $500 billion data center worth in Abilene, Texas, right? So, yeah, it's being discussed as the highest level of the government. Yeah.
And there's different, so we talked a lot about hyperscaler data centers, right? There's a different category called co-location where a business can go and just buy data center space. They don't have to build. It is like an apartment complex ready to go. You say, I need 1, 2, or 3 bedroom. In last 6 years or so, the biggest demand has been from TikTok. You name the price, they'll pay the price anywhere on this planet, right?
To keep themselves available.
To keep themselves available. Before that, there was Uber and Lyft. They were just grabbing any capacity available. That's not an AI model that we talked about, right? These are different businesses almost, right? The contracts are written differently. The data centers are built differently. The capacity is sold differently. So that domain, that space is still very, very active, very, very hot.
In the data center nowadays, are there specific compliance requirement, regulation requirement, specific target the data center?
Yes, yeah, absolutely. The Department of Energy is very, very involved. They have a data center division, right? We have industry leaders from Google, AWS, construction, operations regularly, part of congressional hearings. There's committees that dictate every single thing that goes in data center. Construction and operations, right? So construction is one thing, but once you go operational, there's safety standards built. There's HVAC efficiency standards built only for data centers, dedicated for data centers. Yes.
It's a very regulated space because it's a physical space. It's not software. You're building buildings, right? There's fire risk in there. There is biohazard in there, right? I mean, so it is a very regulated space.
But how viable is this for new players? Like when they enter this market, like of course, as you mentioned, it's already been consolidated by a lot of other companies. And since even Rob mentioned that it is a very capital intensive, like the investment is quite high in this. So how viable as a business is it, or is it not?
It is very, very viable, right? I can tell you every single infrastructure company, traditional infrastructure, energy companies that used to build roads and cities, right? And telecommunication, they're all in data center business right now. A lot of them are new, right? When you look at the scale, right? Mark was showing a chart of where we're going. There's no way the existing community, the existing industry can satisfy all of that. There's a huge influx of talent, money, infrastructure coming in that you'll see. So it's not isolated. It's not banned for new players. We see a lot of new players coming in.
But those new players are very well capitalized. You've got to have hundreds, of millions, if not billions of dollars to start.
Sorry, I have a comment. I think you underestimate the demand for data centers in developing countries. I do deployments of AI in Africa. And so when I say, well, we have this AI algorithm running in the cloud, and the first question they ask, whether it's Kenya or Zambia or whatever, where's it going to run? And if I tell them it's in the United States, they said that's a no-no. So in 250 countries around the world, I believe that every country will have a data center, just for their security and whatever it is. So we focus on the United States and China and Singapore, but I think 10 years from now it's going to be all over.
It's already all over the place.
Okay. I'm sure those are my voice.
Yeah, no. I think this is a national imperative, right? I mean, if you're thinking AI is going to be a fundamental game changer, you're going to need to have the AI produced or built in your country, and the only way to do that is to build those factories, which is a data center.
Well, I know we've gone. It's 8:05, and
oh, really? Okay.
I guess you hang around if you have any other questions, but. I enjoyed the conversation and great insights from the team. So,
thank you for joining us.
Thank you all.